derivatives of inverse circular functions. So for the inverse of sine x, we have this as the derivative. 1 divided by the square root of 1 minus x squared between negative 1 and 1. For the inverse derivative of inverse of cos, we have negative 1 divided by the square root of 1 minus x squared. So the difference between these two is the negative. Also between negative 1 and 1. For the tan, inverse of tan, we have 1 divided by 1 plus x squared, which we could work out by dividing sine and cos anyway. If we have x divided by a, then it becomes 1 divided by the square root of a squared minus x squared. Inverse of cos of x divided by a, negative 1 divided by the square root of a squared minus x squared. And inverse of tan of x divided by a is a divided by a squared plus x squared. So let's put this into practice. Example 8, differentiate each of the following with respect to x. So part A, we have sine to the negative 1 of x divided by 3, which is my x divided by a. Okay, so let me just write the rule. F dash of x will equal 1 divided by the square root of a squared minus x squared. I get 1 divided by the square root. My a is 3, so 3 squared is 9, and my x is x, so I've got 9 minus x squared. So that's part A. Part B, cos to the negative 1 of 4x. Now you've got to realise that 4x is over 1. We'll just write my rule down. So I'm going to get negative 1, the square root of a squared minus x squared. So I get negative 1 divided by 1, square root. 1 squared is 1 minus, my x is 4x, 4x all squared. Now because I've got the 4 in here, I'll have to times this by the 4. Okay, so there it is there. So now when I simplify this, I get negative 4, the square root of 1 minus 4 squared is 16, x squared. Part C, tan to the negative 1 of 2x divided by 3. And there's my x over a. So again, I'll just write the rule at the moment. So f dash of x will equal a divided by a squared plus x squared. So when I do this one, my a is 3, so I've got 3. A squared is 9. 2x all squared is, because that's what my x is 2x, so 2x all squared becomes 4x squared. But because of that, I have my 2 up the top, so there it is there. So I get 6, 9 plus 4x squared. D, sine to the negative 1 of x squared minus 1. So we've got to be careful here. Hopefully I've got enough room. F dash of x. The rule is already in part A, so I won't rewrite it. But I've got my 1 divided by the square root. My a is 1. There it is there. My x is x squared minus 1. So I'm just going to put that in brackets. X squared minus 1 all squared. And remember I have a 2x minus 1. So when I differentiate that I get 2x. Just like when I differentiated the 4x I got the 4. Because I only differentiate the 2x here I got the 2 in part C. So be careful with that. So simplifying this I get 2x, the square root of 1 minus. Now I need to expand this, so I get x to the 4 minus x squared minus 2x squared plus 1, which equals 2x. The 1 will cancel with the minus 1 there, because remember I've got the minus outside the bracket there, so this will become negative x to the 4 minus 2x. I can take sorry, there'll be squared there. So I've got 2x. I can take out the x, negative x. No, I'll take out the x squared. And I've got the square root to there. I've got the square root of 2 minus x squared here. That won't matter. That becomes a plus, remember? Square root of x is x, so that becomes x. That x will cancel with that x, so we get 2 over the square root of 2 minus x all squared. Now this we need to consider a couple of them. Okay, so we've got to consider, which I'll write over here, dy dx will equal 2, because remember square root gives you positive and negative, 2 square root of 2 minus x squared when x is between 0 and square root of 2, and dy dx will equal negative 2 divided by the square root of 2 minus x squared when x is negative the square root of 2 less than x less than 0. So be aware of that.